We are on benchmark 2, page 2, problems 13 through 22. As we've seen, benchmark 1 and the first page of benchmark 2 are very, very similar. And a lot of the things that we did from benchmark 1 were, again, reiterated, practiced again. And so problems 1 through 12 were a little bit of a repetition, which is good. And now we're on number 13 is something new. So it says find the measures of the numbered angles. This actually reminds us of grade 7 coursework, where we have corresponding sides. We have two parallel lines, and we have a line intersecting it called the transversal, and it creates two sets of four pair angles, shall we say. And so when we want to see relationships, so for example, angle 1, we're given one angle, we're given the measure of this angle, which is 63. So what do we know about the other angles based upon that? Well, angle 1 is also 63 degrees because it is vertical. It's a vertical angle. So vertical angles are opposite of each other. Angle 2 is going to be 117 degrees because it is supplementary. Supplementary are two angles that add up to 180 degrees. So 2 and 63 are going to add up to 180. So 180 minus 63 gives you 117. Angle 3 is equal to 117 also. 117, because it is supplementary to 63. It is also vertical to 2, so those are equal. And now, we'll call this angle 4. Angle 5, and we can call that supplementary to angle. Good. So number 5 is going to be 63 degrees. How is that? Well, it is an alternate interior angle. So alternate interior alternate on the transversal are interior to the two parallel sides. Angle 6 is going to be 117 degrees, and it is supplementary to 6. It is also alternate interior to angle 3. And it is also another good one. It corresponds, we haven't done this, corresponds with angle 2. Corresponding angles are the same location on a clock, upper right. So when we go 7, angle 7, we'll say 117 because it's vertical. And then angle 8, we'll say it's 63 degrees because it corresponds with the 63. And that's vertical. So oftentimes when you have this, they ask you why you're coming up with these values. So that'll be important to know those vertical, supplementary, alternate interior, and corresponding. Very important. Find the values of x. Values, there's only one value of x. Value of x, we know that the sum of the angles of a triangle, 47 plus 85, plus x will always equal 180 degrees. So the sum of the angles of a triangle always add up to 180 degrees. Let's add those together. We get 132. And then we can solve for x by subtracting 132. And we get x equals, 48 degrees. So number 14 is going to be x equals 48 degrees. Find the value of x. Okay, so we need to find this angle. We'll call this angle y. So we'd add up 30 plus 118 plus y equals 180 degrees. And that'll give us our missing angle here. So that's 148 plus y equals 180 minus 148 minus 148. We get y equals 32. Borrow 32 degrees. So this angle is 32, and it's going to be supplementary to x. So 32 plus x equals 180 degrees. Now, if we notice, hey, we had something equal to 180 degrees. Oh my goodness. If we subtract 32, we get x equals 148. Yes. What a weird, cool thing. And that is a law, or it is a theorem, is that the exterior angle is always going to be equal to the opposite other two angles. So that's a neat one, that x is going to be equal to the sum of 30 and 118. Real cool. Triangle A has an interior angle measure of x. Interior measures of x 53 and 87. So we have a triangle x 53 and 87. Triangle B has an interior angle measure of 39. Y and 87. Are the triangles similar? Well, they want to know, hey, do they add up? Well, we can find this missing angle, x plus 53 plus 87 equals 180. So x plus 140 equals 180 minus 140 minus 140. X equals 40 degrees, 40 degrees. So that missing angle is 40, and then we have y plus 39 plus 87 equals 180, and we should automatically know that's not going to work because these 87 were the same, and so 40 and 53 need to be identical to that. But we'll do the math anyway. That's going to be 126 equals 180. Did I do that right? 7, 16, that's 9, 12, yep. And minus 126 minus 126, y equals 54 degrees. So are they similar? No, they are not. They have to have the same angles for the interior angles of the triangle. All right, number 17. Profit Y in dollars for a business from selling X games is represented by the formula Y equals 44X. Graph the equation. So graphing the equation, we could do it a couple ways. We can do XY, so we can plug in 0, we get 0, plug in 1, we get 44, plug in 2, we get 88, plug in 3, we get 132, etc. ... So if we want to graph the equation, we're going to make a chart, and we have an x-axis. I didn't mean to do that. That was weird. We have an x-axis and a y-axis. Our x-axis, this one, is the number of games. So that is the number of games sold. And that's going to be 0, 1, 2, 3, 4, 5, 6, 7, etc. And then on the y-axis is the profit. Y equals the profit. So profit, and that's in dollars. Okay, and so 0, 0 is 1 point. And now because we get pretty big, we're going to do increments of 44, and that'll just help us. Those increments do not need to be the same. This is going to be 44, this is going to be 88, it's going to be 132, etc. So we have 0, 0. We have 1, 2, 3 games, 4 games, etc. We have 2 is 88, 3 is 132, etc. And I would just keep making dots here. I would be making dots. I would not connect the dots here. And in the answer key, they actually connect the dots, but you can't buy a half a game. You can only buy single games. So this is not going to be continuous. It's going to be discrete. Very important word that you should have learned in 7th grade. So that's where I differ from the answer key. So hopefully it makes sense. 18, the distance y in miles that train A travels in x hours is represented by the equation y equals 60x. The graph shows the distance that train B travels, which train is faster. Now this can be continuous. It's not discrete, and it's continuous because you can travel, less than an hour. So this train B travels in 1 hour, 78 miles. So B is traveling at 78 miles per hour, and A travels 60 miles per hour. Because you plug in 1 hour, you get 60 miles out. So the graph shows the distance, which train travels faster. B travels faster because it goes 78 miles per hour. Number 19. Solve the system by graphing. Okay, this is a good one. I don't know why I didn't. This is an interesting way of showing this. This is really good. I actually like this problem. So we're going to let's do this in green. So we use the y-intercept, which is 5. 1, 2, 3, 4, 5. We make a dot. We're going to use the slope, which is -4. Down 1, 2, 3, 4. Right 1. Down 1, 2, 3, 4. Right 1. And now we have let's make it green. We have all the solutions to that equation are represented on that line. And we can do pen green, and it goes on forever. There are an infinite number of solutions for this line. And now we'll do the other line. Let's do it in light blue. Y-intercept of -1 with a slope of 2, up 2, right 1, up 2, right 1. And we already see our solution. Hopefully you see that solution. But we'll do this. We'll connect those dots. And these are all the solutions to that equation. Let's do that in blue. They're an infinite number. And the solution is going to be the point where they intersect, which is 1, 1. So the point of intersection where they both have a solution, they share a solution. It's what we call true, true. It's true for the blue, true for the green. This point is true for green, but false for blue. It's not on the blue line. And this point, we'll even take this point over here, is false for green, but true for blue. And then this unique piece is true for both, so that would be the solution. Solve the system algebraically. Okay, so what we want to do is we want to cancel one of these variables. So we can't solve it. We can either do substitution, but this is not set up for substitution. It's actually set up for addition and multiplication. But if I add them, nothing's going to cancel. So I'm going to multiply this entire equation by -1. And that changes the sign for each of those. That becomes -4x minus 6y equals +4. And then I'm just going to bring this. I'm not going to manipulate this equation, and we get that. And now I'm going to combine the columns. The x's cancel. I'm left with -3y and equals 6. We'll divide by -3. We get y equals -2. That's the y solution. That's the y part of the coordinate. And then I can pick either of these, and I can plug in that value. I'll take the lower one, and I'm going to plug in -2 for y, and that'll tell me what my x value is. -6 equals 2, add 6. 4x equals 8, divide by 4, x equals 2. So my solution to this system is going to be 2, -2. Really nice, efficient way of being able to solve a system. You can do it through graphing, you can do it through substitution, or in this case, you can do it through elimination, where we multiplied, we got a proportional equation to it, and then we added. Number 21. You buy 5 balloons and 3 banners for $14. Your friend buys 1 balloon and 1 banner for $4. How much does each item cost? So we're going to write 2 equations. We're going to write an equation for the top one, you buy 5 balloons and 3 banners for $14. And then you buy 1 balloon and 1 banner for $4. So we're going to write 2 statements. We'll write the green one, 5 balloons plus 3 banners. And banners for $14. So off to the side, I'm going to say B is balloons and N is banners. That's how I keep track of that. And then the other equation says 1 balloon plus 1 banner equals $4. And now I have a system. I can either multiply, and I'll do that. I'm going to use the multiplication again. I'm going to multiply this by -5, and I get -5b minus 5n equals -20. Make sure you multiply everything, and then we'll just bring this equation, 5b plus 3n equals 14. Let's combine them. The b's cancel. I'm left with -2n equals -6. Divide by -2. N equals 3. So the banner costs $3. And now I can choose either one. We'll use this equation, b plus n equals 4. I plug in the $3 for the, I plug in the $3 for the banner and then subtract, and I get the balloon equals 1. So balloons are $1. Okay, $3 for a banner, $1 for a balloon. Systems, really important. Determine the number of solutions in a system. So as we know, situations, when you have 2 lines that are on a coordinate plane, they can intersect at one point. So you can have one solution. They can also be parallel to each other, and that is no solution because they don't intersect. And then the other situation can be that they're the same line, and that is infinite solutions. So what is this? These have different slopes. These have the same slope, but different y-intercept. These have same slope and same y-intercept. And these have different slopes. Doesn't matter about their different slope. That's the only thing that's important when you get one. So we look at the slopes. They have the same slope. Same slope of -4, but different y-intercepts. Y-intercept of -1, y-intercept of -4. So they're going to be parallel. So there is no solution. How many solutions? None. They share no solutions. Good? All right. That's it. That was benchmark number 2 for the 8th grade material. We have one more benchmark, benchmark 3. That one's 4 pages long, so that's going to take a couple more videos. But hopefully you liked it. Good luck.